Hello students, welcome to Janon Lectures powered by Wishback Technologies. And in this segment of electronic devices, today we are going to discuss the internal structure of the op-amp. Op-amp is an integrated circuit popularly available as IC741 with 8 pins in the market. An operational amplifier only responds to the difference between the voltages on its two input terminals, known commonly as differential input voltage, and not to their common potential. Then, if the same voltage potential is applied to both terminals, their resultant output will be zero. An operational amplifier gain is commonly known as the open loop differential gain, and it is given as the symbol A. The internal structure is shown in the figure. The first stage is a differential amplifier. The second stage is a gain stage, and the third stage is complementary follower stage. Now, coming to the theory, let's start discussion on the stages one by one. So once again, the op-amp internal structure consists of three stages. The first one is the differential amplifier, then the gain stage, and the third is the complementary emitter follower power stage with DC level shifter. First stage, we know that the CE emitter transistor is not easy to fabricate in IC due to large capacitors and high value of resistors. The differential amplifier satisfies the criteria for fabrication with no need for bypass and coupling capacitors and constant current sources. So this current circuit is the basic block for IC amplifiers. When V1 is equal to V2, a current IE follows through the transistor Q3 and Q4. Now, 2 IE current flows through the sink and the current through each of Q1 and Q2 is also at IE. There is no current through RL and the output terminal is at ground potential. Let us note that how a change in current through Q1 and Q3 is causing sourcing and shrinking of load currents by Q4 and Q2 respectively. Let there be a positive increment of delta VB of V1, that is in terminal 1, and delta VB is more positive in this case. So there is an increment of current delta IE through Q1. Since IE plus delta IE is now flowing through Q3. The same current is also passing through Q4, but due to sink requirement of 2 IE of the current source, current through Q2 is IE minus delta IE. So the current through RL is 2 delta IE and the output terminal is positive with VO that is equal to 2 delta IE RL. Q4 is the sourcing load. Thus, a positive increment at terminal 1 produces a positive increment at the output. So, the phase of the output has not been inverted. Terminal 1 is called the non-inverting input terminal. Similarly, a positive increment at terminal 2 produces a current delta IE plus IE through Q2 and IE minus delta IE through Q1 and hence Q3 and transmitted to Q4. So the direction of 2 delta IE through RL is now reversed. That is, Q2 is sinking load current and there is a decrement of VO by an amount of 2 delta IE RL. There is now a phase inversion between input and output voltages. So terminal 2 is known as the inverting input terminal. Non-inverting and inverting terminals are indicated by positive and negative signs respectively. Now, the second stage. The gain stage is a common collector, common emitter, that is CC-CE amplifier. Here, CE provides the requisite gain and CC acts as a buffer to minimize the effect of loading. And now the third stage. The output should perform the followings. The first one is the supply the load current that is rated around 50 milliamperes. Second is it should have a low output resistance that is approximately equal to 100 ohms. Third one, it should provide large voltage swing, ideally peak to peak voltage. And the fourth one is the output transistors should preferably be protected from overrated current. Now the typical input offset voltage, bias current, offset current, open loop gain, CMRR, input resistance, output resistance, slew rate, 0 dB bandwidth that is BW, full power bandwidth, SVRR or PSRR, setting time, rise time that is shown in the table for an op-amp. And with this we have come to an end of this lecture, and today we have learned op-amp internal structure, first stage of internal structure, second stage of internal structure, and the third stage of internal structure, and also the typical values of op-amp parameters. We will meet again with another interesting topic, and till then, thank you and goodbye.